In this video, we are continuing our final exam review, and we will look at an improper integrals example. So this question is from our final practice problems, part 2, question number 4C, and it asks us to evaluate the integral from -2 to +2 of 12 over x to the 4. So I want to begin by giving you the chance to try this problem. So pause the video for at least 4 minutes to really try this question. 4, 3, 2, 1. Pause the video. Pause it for 4 minutes to really try this question. Like with our previous final exam review videos, I'm extending the pauses and giving you a little bit more time so that you can really try these questions. And then when I go through the solution together with you, I'm going to go a little bit more quickly than I usually would because I'm giving more time to try it initially. All right, so hopefully you've done that. Hopefully you paused it for 4 minutes to try it. So the first thing to notice is this function is discontinuous at x equals 0, which is in my interval from -2 to +2. And that makes our integral improper. All right. And as we saw on the last video, when we reviewed these, when our improper integral is discontinuous somewhere in the middle of the interval, we need to split our integral into 2 pieces when our discontinuity is in the middle of our interval. So in this case, I would need to write my integral going from -2 to 0, because that's where it's discontinuous, 12 over x to the 4 dx, and then plus the integral from 0, started up at that improper place, to 2 of 12 over x to the 4 dx. So now I need to evaluate these integrals. So I'm going to pick one to start with. I'll just pick the second one because it has all positive numbers. So let's do the integral from 0 to 2 of 12 over x to the 4 dx first. All right, so this is improper because of the 0. So I got to replace the 0 with a t, the variable, and then I got 2 12 over x to the 4 dx. And now I take this antiderivative. Later I'm going to take a limit with t and let t approach 0 from the right-hand side. So I'll get t to 2, and I rewrite this as 12x to the -4 dx. And now I can do the antiderivative with the reverse power rule. I'll get 12x to the -3 when I add 1 to the power, divide by -3. And then I got to plug in the t and the 2 into this. So if I simplify my function, this becomes -4. And then I bring x to the -3 to the denominator. And I still plug in the t and the 2. So now if I plug those in, if I first plug in, let's do it over here. If I first plug in 2, I get -4 over 2 cubed minus, when I plug in t, we get -4 over t cubed, which gives us, first fraction is -4 over 8, which is -1/2. And then plus, we get 4 over t cubed. So now we are ready to take a limit now that I've simplified this. So my interval that I was looking at was from 0 to 2. And what's making it improper is the 0. So I need to be within this interval, because this is our interval, and then be getting really close to 0. Sorry, I can't remember if I said what made it improper was the 0 or the 2. So let me just say that again. So our function is discontinuous at 0. So what's making it improper is the 0. So when I take this limit, I need to be getting really close to 0 from within the interval. All right, so let me just erase these dots. I need to be getting really close to 0 from within the interval, which means we need to now take the limit. We are going to take the limit as t approaches 0, but from the right. because we're getting close to 0, but from within the interval, which means it's got to happen from the right-hand side. So we will take the limit as t approaches 0 from the right of -1/2 plus 4 over t cubed. So with the limit, first step is usually we try plugging in. So that gives us -1/2 plus 4 over. I plug in 0 with a little plus sign, cubed. But 0 with a little plus sign just means I'm really close to 0, but I'm a little bigger than it. That's what the plus sign means. So if I take a number that's really close to 0, but positive, and then I cube it, I'll end up something still really close to 0, but still positive. So it's just 0 with a little plus sign. So this gives me the -1/2 at the front. And then plus, when you divide 4 by 0 with a little plus sign, you're dividing 4 by something really small, and positive. And by really small, I mean close to 0. And that's going to end up being huge and positive. So this is going to be going to infinity. And then infinity plus -1/2, that is still infinity. All right, so what does that tell us? That tells us that our integral from 0 to 2 that we were looking at, of 12 over x to the 4, that integral diverges. So, in fact, we could say since this integral diverges, since one of our two pieces diverges, that automatically means that the integral we cared about from -2 to +2 of 12 over x to the 4. And whoops, I forgot to write a dx on this one. So let me make sure I put the dx on this one as well. That integral, the original one, also diverges. When we split up an integral into two pieces, for that original integral to converge, each of the pieces needs to converge. So here, because we saw that one of our pieces does not converge, it diverges, that automatically means the original one also diverges. So that's kind of nice. It saves us some work. And that is our answer.